To simplify this expression, I'm going to use the sum difference formula for tangent. So let's first state that formula. Tangent of alpha plus or minus beta is equal to tangent of alpha plus or minus tangent of beta, all divided by 1 minus plus tangent of alpha times tangent of beta. So if you're adding the two angles, it would be addition and subtraction. And if you're subtracting the two angles, it would be subtraction and addition. So here we're adding, so it'll be addition and subtraction. So let's plug this information into this formula. What we get is tangent of 7 pi over 6 plus tangent of pi over 4, and that's all divided by 1 minus tangent of 7 pi over 6 times tangent of pi over 4. To complete the problem, we just have to know the exact values of tangent at 7 pi over 6 and also tangent at pi over 4. Tangent at pi over 4 is a known angle. Tangent is the ratio of sine to cosine. Sine and cosine are both equal at pi over 4, so tangent of pi over 4 is equal to 1. But what about tangent of 7 pi over 6? What is that equal to? I'm going to use a unit circle to help figure this out. So let's see. 7 pi over 6 is here. So again, this is pi, which is 6 pi over 6. So going pi over 6 more takes me to 7 pi over 6. Tangent is positive in the third quadrant, so I'm going to use pi over 6 as a reference angle. So it turns out that tangent of 7 pi over 6 is equal to tangent of pi over 6. And tangent of pi over 6 is equal to the square root of 3 over 3. I now know these two angles for tangent. I'm going to put this information into this formula. We have that this is equal to root 3 over 3. That's what tangent of 7 pi over 6 is equal to. I'll add 1 to that, so I'll add 1. And divide by 1 minus, okay, this is still equal to root 3 over 3, and this is equal to 1, so I only need to put root 3 over 3 here. And if we can simplify this, it's kind of a mess. We have fractions within fractions, but if we can simplify this thing, that'll be our answer. I think what I'm going to do is multiply the top and bottom by the least common denominator, which is 3. So I will multiply this whole thing by 3 over 3. When 3 gets multiplied to this first part, we have a 3 canceling with this 3, and I have root 3 left over. And when 3 gets multiplied to this 1, it's plus 3. This is divided by 3 multiplied to the 1 gives me 3, minus 3 times root 3 over 3. Again, the 3's cancel, and we're left with root 3. Okay, we're very close to the final answer. The issue is we have an irrational number in the denominator. So I'm going to do a trick to cancel the square root from the denominator. I'm going to multiply the top and bottom by the conjugate of 3 minus root 3, which is 3 plus root 3. So I'll multiply that to the bottom as well as the top. I will do this on the next slide to simplify it. So we will multiply these two fractions together. Just for emphasis, I'm going to include some parentheses. And let's start with the numerator. So first we have root 3 times 3. When I multiply that, I get 3 root 3. Then I have root 3 times root 3, which is 3. Next, I have 3 times 3, which is 9. And then I have 3 times root 3, which is, again, 3 root 3. In the denominator, okay, I have 3 times 3, which is 9. 3 times root 3 is 3 root 3. We then have negative root 3 times 3, which is a negative 3 root 3. And negative root 3 times positive root 3 is negative 3. This is kind of a mess, but some stuff cancels. Notice that in the denominator, since we multiplied this number by its conjugate, the square roots cancel. 3 root 3 and minus 3 root 3 go away. So this cancels with that. So let's see. In the denominator, we have 9 minus 3. That's actually just 6. Now, in the numerator, the roots don't cancel, but that's not a problem. We have 3 and 9, which is 12. And we have 3 root 3 and another 3 root 3, that is 6 root 3. Since there is one number in the denominator, it can divide into both 12 and 6. 6 goes into 12 twice. And, well, 6 goes into 6 once. I'll just write the root 3. And this here is the final answer. It is 2 root 3.